Okay, so where we've last left off here, we have we're reading our first sensor. We're ignoring the second sensor for now. Eventually, we'll use this to control the set point, but now we're just setting the set point here. Okay, then we're going to send that to a function that's going to tell us what, based on the set point and the current value, what I should write the what position to put the servo to. Okay. And for now, we're just using this map function here to do that based on the difference between the current value and the set point. And then to read the sensor, we are using an ultrasonic sensor. And so one of the problems with the ultrasonic sensor, and this is something that when you're going into it, but I think is going to start, is too much of a problem to make this work really well, is that this takes time, because we have some small delays, and all the new sensor we're going to use takes time too, but it doesn't take as much time. But the problem with this taking time isn't that it takes time, it's that it takes an unknown amount of time. So this takes a non-consistent or non-constant or non-uniform amount of time based on the distance, and those time intervals are pretty close, but they're if it misses it, then it goes into this kind of like waits for a timeout, in which case it starts to kind of really push the limits of the cycle that we want to run. And so we need something that's going to operate more consistently and take less time. And so what we're going to be using instead is one of these time of flight sensors. This is like a kind of like a laser range finding system. And so we have this is the sensor right here. It's going to shoot out a beam of light, and it's going to do a similar thing where it's getting a reflection, but because it's light and it goes faster than sound, we are going to be able to have a more consistent time interval. Okay, so I'm going to show you how to update our sketch with that. So we've gone to the libraries, and under Library Manager, we type in VL. Yep, here you go. So I chose the 5.3, the Adafruit one, if I can find it right here. So we're using this one right here, this Adafruit sensor VL53LOX, and then there's different types of these, so you could do something different if you wanted to, but we're going to use that one. And I pulled up one of the examples. Well, in that you can, and under favorites, you search it, then you can search it. So VL. Here we go. And we can pull up examples, and we get this first example here. So we're pulling up this example, and we're going to use this to kind of build out our function, okay, and to modify our code. So come back to our sketchbook. So we're going to start by the top here. So we have to include the library, and we have to make an instance of this object. There we go. So I'll move this down below. Here, like that. Okay. And so now we have created an instance of that sensor, and then if we look down, we'll see that we're going to initialize it here. So this sensor has its own little microcontroller, and it's communicating with us using I2C, and so when we connect it to the Arduino, let's actually pull up the Arduino pin. We want to use the serial clock and the serial data available pins on the Arduino. There's two up here, and the same two are down here. So you can either use these two pins or those two pins. You'll see they're connected to analog pins 4 and 5, and so this is kind of like an alternative function for that pin. So these are the pins we're using, and what happens is we send a message on this one, and the timing of the message is on this one. And so we create a clock signal out this pin, and along with that clock signal, we're sending a message, and we communicate with the board, this board here, using its address. So it has a address that we're communicating with, which also makes it a little tricky to use more than one of these. There's ways around it, but it gets a little complicated. So we're just going to use one of these for the main sensor, and then we'll use the ultrasonic for the second one. Okay, so coming back to here, so in our setup, we're going to call this begin function to initialize it, and what we're going to do is this if statement's going to check to see if it failed to load. And if it failed to load, we're just going to freeze the program here. Okay? And so that's done. All that's left for us to do is to come down here into the loop, and we're going to take a measurement. Okay? And so we're going to copy these 3 lines here. All right, and then come back to here. And in read sensor 1, we're going to delete all this. We're going to put this here. Okay? So what's happening is we create this variable, and something weird's going on here. We'll actually go rid of this. We need to print everything. We're sending. What this means is when we call a function and we pass in a variable, it makes a copy of that number and it sends the copy of that number. What we're doing here instead is we're sending the address to this variable, and so instead of making a copy of the number, it's going to come back and change the value of this. So when we send this variable to this function, when this function returns, this value has been modified, okay, to store the value that it got from the measurement. And then we're going to come back to here, and then we need this line right here. Now there is a chance that we can have a failure. We may want to think about that. Let's see. But for now, we'll do this. Instead of printing, we're just going to return it. Okay. And so maybe we should, so I guess maybe what we should do is if the measurement fails, we should take the measurement again. And all this happens pretty fast. So we're not really at risk of timing out here. Okay, so what we'll do is we'll come back here. So it looks like, if we look at this, if we get 4, then it's out of range. Okay, actually what we'll do then is this. So we don't need to take a new measurement. If we're getting out of range, what we'll do, if it equals 4, here's how we do it. We're going to say float distance equals, and then we'll get, actually we'll set it to, so it's in millimeters, so we're going to say 1,000. Actually we'll set it to max distance. We'll have a max distance value that we can change. So we're basically, if it maxes out, we're just going to set it as our max value. So we're going to say define max distance. So with millimeters, we'll say 3, 4, we'll go 500 for now. We can go back and change that if it's too short or too far. And then what we're going to do here then, if it's not equal to 4, then we're good. And so what we'll do is we'll change it back to here. And if we have a good reading, we're going to modify distance to equal the measure dot range millimeter. Okay, and so what that's going to do is we're going to set it to the max value, and then if we have a good measurement, we'll change it to be the actual measurement we got. And this should be what happens normally, but in some cases it will be out of range. Okay, so we return the distance, and so we have a range, and so this is giving us the distance in milliliters. I actually think it might be an integer, but we'll go with a float for now. We can go back and change that later. And then, so we return that, but now everything is in millimeters, so we have to kind of make some changes here. So we want to set this set point to be millimeters. So currently it's in centimeters. Let's change that to millimeters. Okay, so that's 150 instead of 15. Coming back to here, we want to change these min and max values to also be in millimeters. And now we should have this set up so that it's reading this sensor and giving us, sending it, passing it. We're reading that sensor, we're getting that value now in millimeters. We're passing to servo position. Our set point is also now in millimeters, and I think actually, I'm not sure how much more or less precise this is in the other one, but at least we're going to be more consistent on the timing. Okay.